Number 19 here, they're asking us to find a general solution to a Diffie Q. There's no initial condition that's given to us here, so we just got to try to find out what y is. And this one doesn't look super hard at first, but it does have one thing that's just kind of hard to get used to with differential equations at the beginning, and that's the idea that addition and subtraction, while they seem simpler than multiplication and division, addition and subtraction are actually harder to deal with than multiplication and division are. So what we're going to need to do right here, I believe, is to subtract that 5y and get that to the other side of the equation. So that's going to give us a 2, and I'll go ahead and rewrite y prime as dy dx, and that's going to get us then a negative 5y plus 4. Now, if I could do any factoring on that right side, I definitely would, but I can't. So what we're now going to do is treat this right side as one big factor right here, and now go about our separation of variables. So what I'm going to do here, guys, is I'm going to divide both sides by that negative 5y plus 4, or multiply by its reciprocal there. So just as long as I do the same thing on both sides, I should be fine. We definitely need to move the dx, so I'll multiply both sides by that. And I've got a feeling I might do this differently than a lot of you guys would choose to do. I'm going to move this 2 as well. Now, it's a constant. It's not a big deal. You absolutely could leave the 2 where it is and then anti-differentiate the left side as it's written, but I just think it's going to be better if we can get that 2 completely out of the way, so I'll put that in the denominator on both sides here as well. All right, so with all that in mind, everybody, I think things are about where we want them to be. And I think now we can start canceling some stuff out. dx and dx on the left are gone. The 2 and the 2 are gone. And so I think that left side then is going to become a 1 over a negative 5y plus 4 and a dy at the end of all that equals. And on the right side, the binomial cancels out, and I think that's it. So it looks like then we have a 1/2 and a dx there. Okay, so it's a little messy, but we've completely separated our variables right here, and we're ready to go ahead and anti-differentiate both sides. So, good practice here on the left-hand side. Anytime we're anti-differentiating a constant divided by a linear function, that antiderivative is going to be the natural log of the absolute value of your denominator. So 5y plus 4, but people forget this a lot, divided by the derivative within. So the derivative of that negative 5y plus 4 is negative 5. So I'm going to multiply that by a negative 1/5 out in front of that. We forget that because it seems like in the majority of problems that we're dealing with here out of the book, this denominator here is just a y and it doesn't have a coefficient. And obviously you can get away with ignoring or forgetting to divide by the coefficient if that derivative within is 1. So as I said, good practice for us right here. That's our antiderivative of the left. And on the right, we're just anti-differentiating a constant. So that's just going to be a 1/2 x, and we'll put a plus c at the end of all that. Now again, if there were an initial condition up here, we would probably put that in for x and y and try to solve for c right now. But this is not an initial value problem. They're just asking us to find a general solution. So we need to get y by itself. First thing we're going to do is get rid of that negative 1/5 by multiplying both sides by negative 5. So I'll get a little sloppy with my notation here, guys. There you go, and a negative 5 here as well, and that'll cancel out. So we'll have a natural log of the absolute value of negative 5y plus 4 is equal to, a negative 5/2 x. And then remember, guys, when you multiply negative 5 times a constant, it's not necessary to write this as minus 5c. Minus 5 times c is just another constant here, and since we're not declaring a value for c, we can just leave that as plus c. So when I use the phrase fuzzy math, that's kind of what we're talking about right here. A constant times a constant is still a constant. You don't have to say that it's 5 times that. Okay, moving right along. We're going to get rid of this natural log by exponentiating both sides, and really the equals should move down to here right now. The e and the natural log cancel. So we get the absolute value of negative 5y plus 4 is equal to, now, this is where things get interesting, and there's not necessarily one right way to do this, but what authors and solution writers will usually do is write this then as e to the negative 5/2 x power multiplied then by e to the c. All right, you would add those two exponents when multiplying, and that's where this comes from. And the reason people like to do that then is that, again, kind of like the fuzzy math we were just talking about here with the -5, e, which is a constant, raised to a constant power is another constant. So very often we'll write that as a capital C out in front and then multiplied by e to the -5/2 x power. That's just a little neater than what we could have written right over there. Okay, moving right along here, guys, we now need to get rid of the absolute value. And we do that by just putting a plus or minus in front of the right-hand side. So -5y plus 4 would equal plus or minus c, capital C, times e to the -5/2 x. And yet again, though, something weird and fuzzy happens right here. C is a constant, which by its very nature can be either positive or negative. And unlike an initial value problem, we don't have enough information for them to ask us to determine which one it is. So you can ignore the plus or minus if there's a C in front of all that. Okay, and then from there, guys, we're almost done. We need to subtract a 4 from both sides, so -5y is equal to c e to the -5/2 x, and then a -4 at the end, and then we'll divide everything by -5. Now, something fuzzy is going to happen here as well. Those cancel, and this should be our final statement, guys. Y is equal to, and let me remind everybody for the 1, 2, 3, I guess the fourth time in this problem, here you go. A constant divided by -5 is still a constant. You don't need to put the -5 on the bottom right there. So it's some constant times e to the -5/2 x power, and then that'll be a plus 4/5 at the end of all that. So that, I think, is about as good as we can express this solution here for problem number, I forgot what problem number it was, number 19 in section 9.1.